Part 2 of this module will discuss the other aspect of aquaponics, hydroponics. Hydroponics is the growing of plants without soil. Now, while hydroponics might look a little bit high-tech as judging by this picture, it's not new and we have been doing it for ages. Early pictures depicting the Hanging Gardens of Babylon show that people were trying to grow plants using water on walls and pillars in some of our ancient temples. We also know that the Aztecs were utilizing hydroponic principles in their chinampas. They floated these gardens and grew things like lettuce, tomatoes, corn, cabbage on waterways that surrounded their cities. We learned earlier in the aquaculture section about how the Chinese have been harvesting carp in the rice paddies and practicing rudimentary forms of aquaponics for thousands of years. There is also hieroglyphic evidence from the Egyptians of using water to grow date palms in sand culture. This picture here gives an indication that Egyptians were carrying water from some distance and physically watering their plants, which is a pretty good indication that the Egyptians were not only practicing tilapia aquaculture, but were practicing date hydroponics as well. There was a lot of interest in hydroponics over the millennia, but it wasn't until about the 1600s when investigations started to figure out how plants grow. The first evidence that we have of experiments to determine the makeup of plants comes from the Belgian Jan Baptiste van Helmont, where he took a willow tree and planted it in a pot of soil. He weighed the soil and watered the plant over 5 years. After 5 years, he reweighed the soil with startling results. He found that there was very little soil loss, and he was quite perplexed. The only thing that he could deduce is that something from the water was allowing the plant to grow. Well, it was later in the 1600s when an American named Woodward and others in the early 1600s started doing experiments to try to figure out what was in the plants and what made up plants. And they came up with a list of essential and beneficial elements in higher plants. So we have 21 elements here that plants need in order for them to be as efficient as possible. So there are 3 elements considered non-mineral elements. These are hydrogen, carbon, and oxygen. These elements are naturally occurring in the environment. So as plant physiologists, we don't consider those being part of the essential elements. They get hydrogen, carbon, and oxygen from the atmosphere. There are minerals that we call the essential mineral elements. Now, these minerals are essential for plants to grow. Without these minerals, plants don't grow. There are also 4 other elements that scientists have found that are beneficial for the plants, and they help plants grow better. Now, I recognize that there are several different letters on this page, and it can be quite confusing to figure out what it is plants need. Now, when I was studying my bachelor's degree at the University of Hawaii, I had a silly professor that taught us a mnemonic, a way to remember all of these elements. And so what he told us was that we had to head on down to the C. Hopkins Cafe and go meet our cousin Bomo the Mighty Man and his girlfriend Sakona. He told us that they knew the best way to learn elements. So right after class, what did we do? We went over to the C. Hopkins Cafe and found cousin Bomo the Mighty Man, and met his girlfriend Sakona. Yeah, I know it's a pretty ridiculous way of remembering things, but I found that it's the funny or silly things that allow us to remember some of the more important aspects of stuff that we're trying to study. Well, years after we discovered what makes plants grow, a gentleman in California named W.F. Gierke devised a variety of ways to utilize hydroponics to grow plants and began to show that he could grow plants bigger and more productive than anybody else in the industry. We can see here from this picture that this guy had grown tomato plants over 12 feet tall back in the early 1920s. Another leader in early hydroponics was Dr. James Sholto Douglas. James Sholto Douglas comes from the United Kingdom, and he took the concepts of hydroponics to India in the province of Bengal, showed all of these folks there these different principles, and within a short amount of time were able to create an industry of hydroponics that was quite robust and quite developed, as shown by these pictures that I captured from his 1950s book. I don't know about you, but I am extremely impressed by seeing tomato plants that are 12 feet tall. And another industry that was impressed was the military. During this time, the United States military was going to war and trying to figure out how to feed their troops. Well, they took this concept of hydroponics and implemented it for their GIs on Pacific Islands and grew things like tomatoes, peppers, and salad greens in the gravelly substrates that were on some of these islands. You can see this guy here inspecting a wooden box of produce. Now, the era during the war gave rise to plastics, and plastics significantly advanced the hydroponic industry. We now have facilities that span acres and are able to utilize glass and plastic to grow a variety of crops like cucumbers and microgreens, as well as lettuce and other things. So we see pictures of Green Empire Farms and Leaf Farms. These are two farms on the East Coast that are using hydroponics quite successfully and growing a significant amount of food. Of all the relevant research that I've mentioned so far, I want to highlight one of the leaders in the industry. Dr. Howard Resch out of British Columbia is considered one of the foremost experts in hydroponic food production. He has created the book Hydroponic Food Production, which, as you can see, is in its 6th edition, suggesting that it has become very valuable for those that want to grow plants without soil. So I mentioned earlier the father of aquaponics, Dr. James Ricosi, and his interest in this field. He was able to draw from Dr. Howard Resch's experience, and his 2004 paper that updates us on his aquaponics systems cites Dr. Howard Resch's hydroponic food production from 1995. So I don't know about you, but years ago when I found this out, I decided that I needed to do what the experts do and follow in their footsteps. So I got myself the same book and used this book in order to understand the principles of hydroponics and get an overview of the variety of techniques and principles that would allow me to be more successful. Now, I like to advocate this idea of principles before particularities. We want to make sure that we understand the principles rather than digging into details. And by starting with principles, we're setting ourselves up for more success. So we will cover a couple of the different techniques to give you an idea and show you where this information can be found in this book. These ideas will allow us to better understand aquaponics as we're moving forward in our journey. We have an image here depicting the variety of setups, and there are a variety of mediums that you can use to produce food hydroponically. We are familiar with water, but the roots do like to have something to hang on to at times. So you can see in this picture from the drip system, the aeroponic system, they have something that the plants or the stem of the plant is hanging onto. In hydroponics, we can use things like gravel or sand, like we learned about the Egyptians growing dates. There is a medium called rock wall, which is basically we take rock and spin it like cotton candy and then condense it. It's an inert media, meaning that it doesn't have any nutritive value. Perlite is another really good medium. It's volcanic rock that's broken down into small, manageable pieces. Another really fantastic medium in hydroponic culture is coconut coir, which is coconut that's been broken down, either shredded or blended and chipped into some kind of a medium that you can use to plant in. So it's the principles of hydroponics that fascinate me, because we can use these principles in a whole different variety of ways. I think that there's some really neat things going on out there, so I would like to highlight one of the most fascinating ways. We discussed that there are places in the world where people live and there is very little access to fresh water. So using these principles of hydroponics, they've been able to come up with some pretty interesting ways to solve their problems. Now, we can take seawater and convert it into fresh water and use that water to grow plants. There are some examples of this going on right now in Australia at Sundrop Farms. They're pulling from the ocean just south and taking that water and using solar conversion technology, as evidenced by all of those mirrors there, and then using that water to grow plants in all of the structures to the left of that tower. Another example is the Ashkelon desalination plant in Israel. It is one of their premier desalination plants, and it works in conjunction with a nuclear power plant and growing operations to provide both water and energy to provide food for the local population. We have seen that hydroponics has been around for thousands of years and has come from rudimentary harvesting of fish in rice paddies to sophisticated building of ponds in ancient Roman provinces. It's extremely high tech these days. We are able to grow hydroponic plants using those different techniques in places that we never thought we could grow food before. So we are growing food indoors under artificial lighting. The artificial lighting advances that we saw during aquaculture also lend themselves to growing food. We're able to grow food in the Arctic in geodesic domes where we can control the environment. And we're able to take this concept and scale it up into a vertical application. The picture in the top right is from a TED Talk by Stuart Oda, and he is discussing the future of vertical farming involved in agriculture. And he believes that the future of agriculture is in being able to come up with ways to produce this stuff vertically in the smallest space as possible. And I've went ahead and included the link to watch that video if you'd like.
Indoor vertical farming is a relatively recent phenomenon, commercially speaking. And the reason for this is that consumers care more about food safety and where their food comes from. And also, the necessary technology to make this possible is more readily available and lower cost.
Thank you, and this concludes our module on basics. We look forward to seeing you in Module 2.